Hello everyone, myself Kavya. I'll be starting the plant sciences course, and I'll be teaching biochemistry and other minor subjects along with the major subject plant breeding. So I have completed my UG from GKVK, and I have completed my masters at IRI Delhi. Currently, I'm pursuing PhD at IRI Hyderabad. I've cleared JRF, SRF, CSIR, and also SRB net. Uh, Today we'll be starting with biomolecules in that protein. First, before starting that, I would like to say that for the why to read biochemistry or why to cover it, because everybody will cover the major subjects. Nobody is going to cover the minor subjects. If you cover the minor subject, that will be an added advantage to all of you in order to tackle the exam. Uh, so if the syllabus, when you open the syllabus, you can see that there are concepts like structure and function of protein, carbohydrates, nucleic acids, enzymes, and vitamins. So out of this, I'll be covering all, and only the basics of these subjects, like these topics I'll be covering. If you need any extra information or in-depth information, if you have any doubt, you feel free to contact me or feel free to ask that doubt in the class. Coming to the questions that I have seen in all the years. So in all the years, you can see one question from biochemistry coming. So that can add extra marks, and that can fetch you less rank also. So this question, if you see, this question they have asked amino acids, vitamins, and the hormones, where zeatin, picloram, thiamine, glutamine has been asked to match with their corresponding groups. As we already know, glutamine is an amino acid, thiamine is a vitamin, and picloram is an auxin, and the zeatin is cytokinin. So if you know the concept, then it's easier to answer. The questions like this, you can easily do that. But when it comes to enzymes for DNA manipulation like this, you need clear-cut concepts, like which enzyme does what. And this question, the bonds involved in the protein structure are, what are the bonds that is involved in the protein structure? For this, you need to know what is primary, secondary, and the tertiary structure. This question, most common secondary structure of the protein molecule is. For all these questions, you should know what exactly is the protein structure and what is protein structure. That's why I'll be covering protein in first class, and later classes I'll be giving basics of other topics also. Coming to biomolecules are the carbon-based organic compounds. These are produced by the living organisms. So the biomolecules can be small biomolecules, like they can be monomers, like sugars, fatty acids, nucleic acids, and the amino acids, or they can be large biomolecules, like the sugars will become polymerized and form the carbohydrate. The nucleotides will polymerize to form the nucleic acid. Amino acids will polymerize to form the protein. And these large biomolecules will have the function in the living system, like carbohydrates have energy yielding function, and it acts as extracellular structural element. Nucleic acid and the protein together acts as informational molecules in storing, transmitting, and translating the genetic information. So coming to today's topic, today I'll be covering the protein. So in protein, the important part is the protein. The building blocks of the protein is amino acid, right? What is an amino acid? Amino acid is a compound that is made up of carbon, hydrogen, oxygen, and nitrogen, and it serves as a monomer for the proteins. Amino acid, as the name itself suggests, that you can see amino has an amine group, and here the acid has a carboxylic acid group. So amino acid contains two groups majorly, that is amine group and the carboxylic acid group. So as I already told, that biomolecule is a organic compound. So these biomolecules contain the carbon skeleton. Like that, the amino acid is also made up of the carbon skeleton. If I can name the carbon skeleton, I can name it as alpha, beta, gamma, and delta. So in amino acids, if the amine group is attached to the alpha carbon atom and the carboxylic acid is also attached to the alpha carbon atom, we call it as alpha amino acids. If amine group is attached to the beta carbon atom, we call it as beta amino acids. If it is attached to the gamma, we call it as gamma amino acids. Alpha amino acids are important because these are naturally occurring amino acids and most commonly occurring amino acids, if you can see. Coming to the structure of amino acids, for the structure of amino acids, there is a basic structure for all the amino acids. That is, we'll be discussing only the alpha amino acid structure. You have a central carbon atom to which the R group will be attached, and we already know NH2 is attached, and the COOH is attached, and the H is attached. Since the valency of the carbon is 4, 4 groups are attached. To give an example that R group is variable, I'll give 3 examples. So the first one being the most simplest one, that is H. If this R group is replaced by H, it becomes a glycine. What happens in case of glycine is you will have H in 2 sides. Remember the structure of the glycine, which we'll be discussing later, because in case of lysine, what happens? You will have extra amino group. After up to epsilon C, after epsilon C, you will have extra amino group, which is called as secondary amine group. And one more exception is that proline. Proline is an exception and unique because in proline, if you look at the side structure, it makes the bond with the amine group and it forms a ring structure. That way, it becomes secondary amino acid. Proline becomes secondary amino acid. It's not a primary amino acid. So if you look at lysine and proline or any other amino acid for that matter, except glycine, you have the central asymmetric carbon atom. The carbon atom is bonded to the 4 different groups. But in glycine, the carbon atom is bonded to the 2 same groups. Here, this is not asymmetric. This molecule containing at least 1 asymmetric carbon atoms, if you have a molecule that contains 1 asymmetric carbon atom, at least 1 asymmetric carbon atom, we call them as chiral molecules. Coming to the properties of amino acids. What are the properties of these amino acids? Amino acid can act as both acid and base. As I have already drawn the structure of amino acid, you can see here that this is an acid. Acid in the sense it can give up a H plus. This is a base. It can accept a H plus. Usually in the physiological pH, amino acids exist has the zwitterionic form. This is the zwitterionic form and the net charge on the amino acid is 0. But the side chains of the amino acids can vary and it can change the charge of the amino acid at the physiological pH. That is also possible. So since it can give up H plus and it can take up the H plus, let's see how it will behave in lower pH and the higher pH. If you look at how it will behave in the lower pH, how it will behave in the higher pH, can anyone say what ion will be abundant in the lower pH? What ion can we yeah. When you keep this amino acid in the H plus environment, the COO minus will take up the H plus. What is the charge on the amino acid at low pH? What is the charge now? I think I have to. These are the side groups of the amino acid. What charge can we expect? Okay, the charge on the amino acid is +1 when you keep it in the lower pH. In the higher pH, which ions will be abundant?
OH.
Yeah, OH minus is abundant. If you look at how the amino acid will take up, this CO minus already has given up the H plus. Even NH2, NH3 plus will give up the H plus. So what's the charge on the amino acid in the higher pH?
-2.
-1.
Yeah, -1. So for amino acids at the lower pH, I'm talking about just the two groups without taking into consideration of the side groups. It is in the lower pH, it will be +1, and in the higher pH, it will be -1. So due to this property that amino acid can behave as both acid and base, it is called amphoteric compound. And because it can give up a proton, accept proton, and it can donate a proton, it is also known as ampiprotic. So coming to the next important property, that is the optical property of the amino acids. As you can see here, I have already told that this is not an asymmetric carbon atom. Here in the glycine, if you see, you have 2H attached to the carbon atom, and wherever you search, you don't get any carbon atom that is attached to 4 different molecules. But here you have, in proline, you can see an asymmetric carbon atom. Lysine, you can see asymmetric carbon atom. So this lysine or proline or any other amino acid except glycine are all chiral molecules. They all contain asymmetric carbon atom. So due to the presence of this asymmetric carbon atom, they get some optical properties. What can somebody say? What is optical property? What does it? What can it indicate? Okay. Optical, has the name suggests, it is something related to light. So when we pass the plane polarized light through the solution of the amino acid, how is it going to rotate the plane polarized light? That is the optical property. So if it is going to rotate it in the right side, handed fashion, we call it dextrorotatory. I mean, if it rotates in the clockwise direction, we call it dextrorotatory. If it rotates in and counterclockwise direction, we call it levorotatory. So one more coming to the definition of specific rotation. One more thing, like I'll not be going too detail into the topic. I'll be going superficially. So at any point, if you people can't get, please alert me. So specific rotation, the specific rotation definition says that the quantify, it is the optical rotation that you are going to get at the standard conditions, like 1 gram per millimeter of the concentration and the 1 decimeter of the path length. So this is known as specific rotation. As we are discussing the optical property, one important thing is, how do we decide the structure of the amino acid? We are talking about the optical property, but what about the configuration of the amino acid? Is there any way that we can find out the configuration of amino acids? So amino acids, except glycine, excuse me. Amino acids, except glycine, all exists in 2 configurations. So these 2 configurations are all non-superimposable mirror images of each other. Non-superimposable mirror images of each other. So they are called enantiomers. So in order to define the configuration of amino acids, there are 2 systems. One is DL system and the other is RS system. DL system is simple, that you have already seen. It is just like the glyceraldehyde. In the glyceraldehyde, you will have aldehyde group, and you will have OH group. You will have CH2OH group. So glyceraldehyde can exist in two conformations. If the OH group lies to the right, it is called deglyceraldehyde. If the OH2 exists in the left, it is called L-glyceraldehyde. In the same way, for the amino acids, they'll take into account the amine group. So for the amine group, if the amine group is in the left, they call it as L-amino acids. If the amine group is in the right, they call it as D-amino acids. They call it as D-amino acids. Usually in the nature, you get to see the L-amino acids. These are most common. If you look at the 22 standard amino acids that are ribosomically incorporated, they are all L-amino acids. So the D form where you can find is, you can find them in antibiotics and the peptidoglycan cell wall. Coming to RS system, in RS system, you don't have any reference. You just consider the atomic number of the elements or the atomic number of the side chains. Based on that, we prioritize it. For example, if you have sulfur, that will have the highest priority. If you have OH, that will have the next priority. If you have NH2, that will have the next priority, and COOH next. Like that, you will have the priority based on the side group that is attached. Can anybody say sulfur containing amino acids?
Methionine cysteine.
Yeah. In that case, like this priority works in that case. That's why sulfur is included here. That the side chain priority will be taken into consideration in case of RS system. Since this and the central carbon atom will be given the least priority, and it will be shown that it is going away from the observer, and the other chains will be indicated. If the chains are arranged in the clockwise direction, then it is called clockwise direction is called, excuse me. If it is the clockwise direction, it's called R form. If it is the anti-clockwise form, it is called the S form. So R stands for rectus and the S stands for sinister. All the L amino acids that we have discussed will have the R configuration except lysine. Can anybody say why? Can anybody guess why? Sorry, except cysteine. Except cysteine, all will have the all L amino acids will have the R configuration. You can guess it. You already told that cysteine has something that can change its priority. Cysteine has SH. That's why it can change the side chain priority. When I show you, when you look at the side chains of amino acids, you will get an idea. If you look at the cysteine here, cysteine is there, no? So cysteine has SH in its group. That's why when I'm talking about side chain, I'm talking about these groups that are shaded here. Okay. There are one more thing is standard and non-standard amino acids. So there are 22 standard amino acids. These standard amino acids are ribosomically incorporated into the protein. Non-standard amino acids occur in nature, but not ribosomically incorporated. So in 22 standard amino acid, we study 20 standard, let's see the 20 standard amino acids and their configuration, their classification. As I have already drawn the basic structure of amino acid, that is, you will have extra R chain NH2 here, COOH here, and H here. So this R group keeps on changing from amino acid to amino acid. This is glycine. I have already told. Alanine, where you have methyl group, and in the proline you have the ring structure. Proline ring structure is important because of its ring structure. It makes it sterically rigid, and it can't participate in the alpha helix or the other conformations like secondary structures. Coming to like valine, you have a branch structure, and leucine, you have a branch structure. Methionine, there is sulfur here. Aromatic amino acids, phenylalanine, tyrosine, and tryptophan, they all have rings, like phenylalanine has phenyl ring. This is important. They can ask which amino acid has which ring. Phenylalanine has phenyl ring. Tyrosine has 4-hydroxyphenyl ring. Tryptophan has indole ring. Histidine has imidazole ring. And the classification, coming to the classification, you have coming to the classification, you have non-polar R groups, where you don't have the polar side chains. Can anybody say the difference between polar and non-polar? Anybody has to say, because I'm not getting whether you are getting the class or not.
Ma'am, it depends on charge.
Yeah, whether it depends on whether it contains in the side chain the electronegative or the electropositive atom or not. So coming to these aliphatic amino acids, they have non-polar side chains. As you can see, H is not polar, CH3, and this is not polar, valine and leucine, isoleucine, methionine. So coming to aromatic, they don't contain polar. Only phenylalanine and the tryptophan are non-polar. Tyrosine is polar. Can anybody say why?
OH group.
Yeah, because of the oxygen, it becomes polar, but it is polar uncharged. It comes under polar uncharged. And in polar uncharged, you have serine, threonine, cysteine, asparagine, and glutamine. Asparagine and glutamine contains amide groups, carbamide groups. So this asparagine, where the amide group will be replaced with the H to give rise to aspartate. It is negatively charged, and these are acidic. Remember, acidic amino acids are negatively charged. Why is it negatively charged? Why CO is written as minus here?
Because it has given its H plus.
Yeah, all amino acids that we have mentioned here, these are all in the physiological pH. We are talking about these amino acids in the physiological pH. That's why the basic amino acids will have the plus group. Like if it contains NH3, it contains the plus group. It contains NH, it becomes plus group, and if it is acidic, it is negatively charged. So in positively charged and polar, you have lysine, arginine, and histidine. Twenty-first and 22nd amino acids. We discussed about 20 amino acids. 21st amino acid is selenocysteine. Selenocysteine resembles cysteine. Selenocysteine resembles cysteine. Only thing is, in the place of cysteine, it will have in the place of sulfur, it will have selenium. It will have structure similar to cysteine. In the place of that, it will have selenium. Selenocysteine, the genetics course is over, no? Selenocysteine is encoded by which codon?
UGA.
So, yeah, it's a stop codon. Selenocysteine has its own tRNA or not? If if it is coded by a codon, it should have its own tRNA, right? The
Yes.
anticodon is UCA. Anticodon is UCA, and to the tRNA of the selenocysteine, serine will come and bind. If you have observed here, serine also has the same structure as that of the cysteine, but in the place of S of cysteine, you have O. This O will be replaced by selenium to make selenocysteine. This is where maximum time we get confused that selenocysteine is the modification of the cysteine. No, it's not the modification of the cysteine. It's the modification of the serine attached to the tRNA. Coming to pyrrolysine, anybody knows pyrrolysine is coded by which codon?
UAG.
Yeah, CUET. Where do we find selenocysteine? It is found in glutathione dehydrogenase enzyme and the formate dehydrogenase enzyme. Glutathione peroxidase and formate dehydrogenase. This completes the standard amino acids. What is pH? What is pH?
Negative logarithm of hydrogen ion concentration.
Yes.
Logarithm of hydrogen
that's
ion concentration.
okay. Negative logarithm of the hydrogen ion concentration. If I give you 0.1 molar HCl, what will be the pH? Point 0.1 molar can also be written as 10 power minus 1, and the pH is negative logarithm. So 10 power minus 1, pH will be 1. So pH scale ranges from 0 to 14. I think that's it. They are going to ask you all regarding pH. So in amino acid, one more important point is isoelectric pH. Isoelectric pH is the pH at which the net charge on the amino acid is 0. As we have already seen, for uncharged amino acids, you will have almost same isoelectric pH or the PI. But for the charged amino acid, the PI is going to change. Why are they called? Can anybody say this aromatic? These three can absorb the radiation or not? Just a guess. Can they absorb the radiation or not?
Yes.
Yeah, they can absorb the radiation. So the order will be tryptophan will be highest, tyrosine will be next, and the phenylalanine will be least. These two will absorb the radiation at 280 nanometer. This will absorb at 257 nanometer. Usually we use these if a protein contains these groups, like these amino acids, we'll determine the protein concentration using the absorbance value of these amino acids. Proteins are formed by which bond between amino acids?
Peptide bond.
Yeah. So peptide bond, or also called as amide bond. It's a dehydration reaction where you have COH and you have H here. You have NH2 from another amino acid. This OH and H will pair up. It will give out the H2O, and they form the peptide bond. C double bond O, NH. Important point, what they can ask is whether it has partial double bond character or not. It has partial double bond character, this peptide bond, because here the O is there, and the partial negativity, the electronegativity of the oxygen makes this CN bond more become partially double bond character, and that makes the protein chain, that is the primary structure of the protein, rigid. The backbone of the protein will be rigid because this CN bond has a partial double bond character. So after the amino acid gets bonded together, they can form peptides or they can form polypeptides. What are peptides? Peptides are those that are made up of 2 to 50 amino acids. They can be non-ribosomically formed or they can be ribosomically incorporated. Non-ribosomically formed will not have the regular synthesis process, like it will not be catalyzed by peptidyl transferase enzyme. It will not be coded by any amino acid. It will not be coded by mRNA. And it can have L or R configuration. Like we already saw that ribosomically incorporated most of the time will be L-alpha amino acids. This can be L or R configuration. And these ribosomically formed peptides will be usually linear and unbranched. These can be cyclic or linear. Example for non-ribosomically formed peptides would be gramicidin and tyrosine. These two are antibiotics. Ribosomically formed peptides would be glutathione, which is a short peptide. And you will have polypeptides that are only ribosomically produced. Polypeptides can't be produced non-ribosomically. Can peptide bond form between different group of, if I say that peptide bond can form between the secondary amine group of lysine and the carboxylic acid group, the gamma carboxyl group of the glutamic acid and the amine group of the alanine, is it possible to form peptide bond like this? The gamma carboxyl group of the glutamic acid. Gamma carboxyl, I mean, it is not the alpha carboxyl group, which usually participates in the reaction. Which carboxyl group usually participates in the reaction? Which amine group usually participates in the reaction?
Alpha.
Yeah. So, is it possible for this amine group to combine with this gamma carbon group, gamma carboxyl group of another amino acid and form peptide bond? It's just a guess, you can guess it. It is possible, and that is also termed as peptide bond. So peptide bond doesn't mean to be formed between C alpha and C alpha. It can be formed between any two groups. Peptide bond is an endergonic reaction. It requires energy in order to form the peptide bond. Okay, during translation, is the energy consumed or energy released? During translation, is the energy consumed or the energy released?
Consumed.
Yeah, it's an endergonic reaction. Formation of peptide bond is an endergonic reaction. Coming to protein structure. Protein structure is important, and in protein structure is important. In protein structure, we have four structures. Primary structure, secondary structure, tertiary structure, and the quaternary structure. Primary structure is simple. Your amino acids will come together. This is your primary structure, which is linear unbranched structure. Primary structure is what it is coded by ribosome, and it contains all the information that is required to form the secondary structure and the tertiary structure. Because secondary and the tertiary structure are formed by the interaction between the amino acid side chains or the main chain atoms only. There is no other information that is being given to form the secondary and the tertiary structure. So primary structure itself contains all the information that is required to form the secondary and the tertiary structure. So secondary structure involves the main chain atoms only. We are not concerned about the side chain atoms. If anybody knows what are the types of secondary structure, do anybody know?
Alpha helix and beta sheets.
Okay. One more is possible. Turns are possible. So alpha helix and beta sheets are regular and they are repetitive. Whereas this is an irregular structure. Alpha helix, as the name itself suggests, your amino acid will become helix with the intra-chain hydrogen bonds. You have C alpha here, you have C here, N here, again C alpha here. So in alpha helix, what happens? H here. How many C alphas came in between?
3.
What does C alpha mean? What does C alpha mean here?
NH2 and COH group are attached to first carbon atom.
Yeah. So this is amino group. Means this is one amino acid. This is amino acid 2. This is amino acid 3, right? So alpha helix is formed within a amino acid chain or the peptide chain with the intra-chain hydrogen bond. Within the same chain, you will have the hydrogen bond between the oxygen of the carbonyl group and the hydrogen of the amine group. This is how the alpha helix is formed. So here you have 1, 2, and 3. Usually per turn, so I'm writing it in terms of turn, like you will have C here, and C here. Its group will form the helix, I mean hydrogen bond. And this will form the hydrogen bond. This is how you will get the alpha helix. So in alpha helix, you will have 3.6 amino acids per turn. From this H to this O, you have total of 13 atoms. That's why alpha helix is written as 3.613, and this is the most commonly occurring form of alpha helix. And in a helix, all amino acids will be either L form or D form. They will not be different. That's why it will be regular and repetitive. Otherwise, it becomes irregular. Coming to beta sheets. Beta sheet is formed between 2 or more amino acid chains. So it can be parallel or anti-parallel to each other. It will be same as, it will look almost like take this amino acid chain. And if you have another amino acid chain over here, another amino acid chain over here, you will have the hydrogen bonding between the, you will have the hydrogen bonding between the double bond, this and this. It would look like that. Sorry. You will, if you have a amino acid chain like this, you will have hydrogen bond over here. These all hydrogen bonds will be parallel to each other. And here it can be parallel to each other or anti-parallel to each other. How do we decide the orientation of the amino acid? How do we decide the orientation of the amino acids? We decide the orientation of the amino acid based on the N-terminal and the C-terminal. So if both the amino acids have the same direction, N-terminal and C-terminal, these beta sheets are called parallel beta sheets. If you have in anti-parallel fashion, these are called anti-parallel beta sheets. One more thing in alpha helix, I forgot to say that in alpha helix, the most common form is the right-handed form. Because it's energetically more favorable. Coming to turns, which are irregular structures. In case of turns, what happens? These turns are not exactly structures. They'll be present in between two beta sheets, or they'll be present in between two alpha sheets. So these are turns. Turns can be of different types, alpha, beta, or gamma turns. Coming to difference between the motif and the domain. Motif is a structure where different secondary structures will form a super secondary structure. That is the motif. Domain is the tertiary structure and it is evolutionarily conserved. If they ask for multiple choice for motif, it's a super secondary structure, which is a combination of the different secondary structures. Whereas domain is the tertiary structure that is evolutionarily conserved. Coming to the tertiary structure. In tertiary structure, we take into account the side chain, but within the polypeptide. So the side chains of the polypeptide, except the main chain, that is your main chain is the backbone that I told, the peptide bond. This is your main chain. Whatever is attached to other carbon atom is your side chain. So these are your side chain. If you have CO or COOH, or you might have SH here. So these are all your side chains. These side chains will interact and form the tertiary structure. Why is tertiary structure important? Tertiary structure is important because it gives the three-dimensional conformation for the protein molecule. So the major interaction in case of tertiary structure is hydrophobic interaction. You can have electrostatic interaction, hydrogen bonds, and the van der Waals force of interaction. Also, you will get to see intra-chain disulfide bonds. You will get to see intra-chain disulfide bonds. Can anybody say which between which amino acids we can expect the intra-chain disulfide bonds?
Sulfur containing.
Yeah. So between the cysteine, we can expect the intra-chain disulfide bond, where you will have two cysteine residues connected like this. Coming to quaternary structure, in quaternary structure, you will have all kinds of interactions like hydrophobic interactions, electrostatic interactions, sulfide bonds. And quaternary structure will have the secondary, quaternary structure will have more than 2 polypeptides. Hence, it can be multimeric or it can be monomeric. Today, I'll be stopping at the protein structure. So if anybody has doubt, you are free to ask. Anybody has any doubts? Or please give a feedback like you people want it in more depth. Like, is it difficult to follow it with such a superficial explanation? Please, somebody has to talk. Is anybody there? You can chat also. I'm not getting any feedback. Does that what for is this S? Is it like I should give it more in depth or is it fine? Okay. 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 If you have any questions, you can. Okay, I'll go slow. Okay, I'll go slow. You could have texted me in between. I would have gone slow. Like slow in the sense you want me to talk slow or you want me to go little bit in depth, like at least little bit more of the concept. Is it becoming too boring? Okay, okay. It's too much of information for a single class and okay, okay, I got it. Okay. Okay. If you have any doubt, please communicate in the Agriadic community. And thank you for the day. Thanks for being patient listeners. Thank you.
Thank you, ma'am.
Thank you, ma'am.